Well, hello, everybody. Right. Okay. I am Dr. Fred. I'm the guy who's going to torture you with chemistry for the next 16 weeks. No, I think it'll be bad. We're going to make it fun, or at least attempt to. Anyway, before I start, I got a few people still trying to get in. Let me do a roll call, and if you will, once I call your name, if you can type your name into the chat, that will be, give me your full name, please, because I have a couple of people who have same first name. So if you type in your full name, I appreciate it. That'll be my list, my official list that you're here. Okay, so now my apologies if I kill your name. I'm not trying to do it. Don't type your name in yet. Let me call your name first. Okay. All right. Okay, we got Mr. Acosta, Anthony Acosta. All right, good. We here. Aratico, we got Roman. Aratico, are you here? I don't see you. Okay. How about Samantha Bigay? Samantha? Oh, there you are. Okay. How about Enrique Cigarro? Oa? Enrique? There you go. Okay, how about Lucian Davis? Where are we at? Are you here?
I had typed it in before
okay.
you.
Okay, got you. How about Delgado? I saw your name earlier. Yeah, I saw you. Okay. How about Faber? Hope Faber. There you go. Thank you. How about Anna Karen Valerio? All right. And how about Angie Lowry? Got you. All right, Megan Luevano. Okay, thank you. Maddie, last name Maddie, M-A-T-T-I-E. Here we go. Mendoza, Ellie. Okay, Alejandra. Okay. How about Maria Ortega? And how about Nikki Petrie? Petrie, I believe. Petrie. P-I-E-T-R-E. Got you. Okay, Marky Stone. Marky Stone, are you here? Let's see you. All right, Castellan. Silali. There we go. Thank you. And how about Long Tran? Long Tran. T-R-A-N, Trent. Oh, there you are. And Trujillo, Alejandra. Okay. And Ellen, is that Virginie? Okay. All right, now, if I missed your name, if you can type it in, and then I'll update my list. I did download this yesterday evening, so it may have not been uploaded. So if I missed your name, please type it in, and then we'll update. Okay, Stephanie. Stephen or Stephanie. Okay. Anthony Acosta, yeah, I got you. The only one missing is Roman Aratico. Are you here? Nope. And then I got Marky Stone. All right, well, welcome aboard. Okay, next 16 weeks, like I stated, we're gonna do some chemistry. So, but what I want to do first is I'd like to introduce myself to you. I know we have an activity where you're introducing yourself to me as a video, so I get to know you a little bit. That kind of helps me a little bit in how to present this class. I kind of have a different philosophy in teaching chemistry. I worked in industry for many years and worked with people in the different levels as far as knowledge of chemistry. So I kind of use a lot of real life experiences, and something hopefully you can relate. I can get as technical as you want, I can get as non-technical, so we'll play it by ear and see how the class goes. But let me introduce myself first, and maybe not, I got a slide here. And let me share this. It disappeared. Oh, there we go. Okay, well, like I said, welcome to chemistry. My job here is to help you get through chemistry. I think the majority, about half of you are nursing majors. About half of my class is nursing majors. This is just a prerequisite to get to your next step. So I don't know what the rest of you, there's a variety of disciplines. So anyway, I'm a homeboy, so to speak. I'm originally from a little town east of here. If you take 60, you go up to Globe, Miami, you're going to pass through a little town. If you drive too fast, you're going to miss it. A little town called Superior. I grew up there many years ago. Left there about 100 years ago and joined the military. So I am a Vietnam Air Force veteran, a civil engineer. After that time, I ended up in Kansas City. And so in Kansas City, I continue my education using the VA benefits and so forth. So I got my bachelor's degree from Avila University. That's where I learned about chemistry because the way they taught, at least my instructor, it was run by Coran DeLay sisters. She really kind of turned it all around. And the reason I say that is because my first chemistry class I took, I totally bombed out. I got a flat out F. I just didn't work out. I couldn't connect the dots. And that's the problem sometimes with the way chemistry is taught. There's no connection of the dots. And I'm going to attempt to do that. I remained in Kansas City. Went on and got my doctorate there at the University of Missouri. My background, as far as academic background, is my doctorate's in organic chemistry, where basically I was synthesizing, making new compounds. Sticking with organic compounds, being mostly carbon, hydrogen, nitrogen-based, sulfur-based compounds. I am retired. My professional career, I'm a retired research scientist. My emphasis was process and product improvement. And so basically looking at a process and analyzing it and trying to figure out, hey, how can I make this process a little bit, thank you, sir, Thomas. Thank you for that. How to look at a process, how to analyze it, how can I make it better? How can I make it more cost efficient? Looking at the products and doing the same, okay? So it got me involved in multiple different industries. I've been teaching now adjunct now at GCC for a time period, about 7 years now. And I also teach at adjunct chemistry at Scottsdale. In fact, I teach there also online on Fridays. And as I offer my 1 o'clock class, I have 2 GCC classes. One starts at 1 o'clock and then you guys are 4:15. And then on Fridays from 1 to 3:30, I offer the same course. Therefore, if you ever find a need that you need to kind of come to one of those classes, because maybe you missed this one, feel free. I have no problems if you come in at 1 o'clock because you can't make it to the 4:15, or if you come in on Fridays for my SCC class. And why I say that is because both classes, both campuses, I utilize the same textbook, same PowerPoint slides. They have a little bit different requirements, but it's essentially the same class. Okay, so that's open up to you. I was prior to doing my adjunct work at Glendale, I was also adjunct with Carrington College. And there, most of my students there were physical therapy and dental hygiene students and respiratory students. I taught chemistry there, general chemistry. I also taught mathematics and physics. So my background is quite diverse with respect to the fields, at least in the sciences. But in my whole career, I've done more than this. I haven't always been a mild-mannered scientist. Okay. In the military, I was in civil engineering, was basically working with, I started pouring cement and working carpentry work, heavy equipment operation, electrical work, all the aspects of building buildings and so forth. So I continued in construction for a time period. Didn't like the hours or the weather, so I said I better look for something else. So I decided to get into academia. My first major was a business major, and I'm like, okay, because I didn't know what I wanted to do, and I was already in my 30s, so it wasn't until later in life that I realized chemistry got to me, and what got to me was electrons. We'll talk about those crazy electrons. Anyway, I also did work in customer service. I've been in food and retail industry. Did a lot of programming, software programming. The company I worked with required some software, in which I did that. And then I did a lot of caregiving for my late wife. So I have 9 children, and I got a new one too. Actually, I got a 2-year-old, and I got 9 grandchildren. So I'm still going strong here. Okay. So even though I'm retired. Anyway. What I want to do now, that's enough about me. My job here is to teach you chemistry to help you pass this class. Okay, it's going to take work from your end, and nothing's free, and it's going to take some work from your end to put it all together so you can pursue your educational goal, whatever that may be. But I do know that piece of paper that you eventually get. I never believed that I would be doing research that on products that would be sent around the world. You know, coming from a small town of Superior, small mining town, and but I couldn't have done it without that piece of paper. Okay, so it does open up a lot of avenues. What I want to do, feel free if you have any questions. I want to get into just certain aspects of the syllabus, because it's there for you. I emailed it to everybody. It's on the Canvas course. You can read the rest, the details at your leisure. But there are some aspects that I want to make sure we understand. Okay, so this is the syllabus I sent you. Obviously, you know how to get to this class because you're here. But if you don't want to hit that link on the Canvas course, you can use your Zoom app, and there's my meeting ID, and there's the passcode to get into this class. Okay. All right. So tutoring, for example, is being offered, and there's a link to tutoring. The important aspect about this chemistry class is you've got to work hard not to get behind, because I said earlier about connecting the dots. Chemistry is about connecting the dots, learning some aspect about the chemistry, and then using that for the next step. And so if you don't get one part of those dots, get help. Don't hesitate 1 minute to email me. We can set up tutoring now. I don't want to say tutoring. I'm not required to have office hours, but I do offer them, and I do offer them between 3 and 4. Okay, 3 and 4 p.m. Thursdays and Fridays. Okay, right here, by appointment. So if you need help, get help early. Okay. Also, tutoring is offered through the campus. So I gave you the link there for the tutoring website, and there's a tutoring schedule. Tutoring is offered on campus. And also you can do it online. I think it's called BrainFuse if you need it. BrainFuse can be used for multiple classes, not just chemistry. But you have tutors that are from all the way from morning to like late evening, afternoon, I should say, on campus if you need it. So you need assistance, get it. Don't hesitate to get help. And do not hesitate to email me any questions. You know, sometimes students are like, well, I don't want to bother you. Yeah, that's my job. Okay. That's my job to help you out. You got a question? You know, you're the customer. I'm here to make sure that I can do what I can to help you with the chemistry. So do not hesitate to send me an email. 90% of the time, email can answer the question for you. If that doesn't work, then we'll set up a Zoom time, okay? Or you can go on campus and talk to one of the tutors. There's a course website, which I gave you the link. Everything on that course website with respect to text files, which you don't need a book, because all the chapters are given to you in PDF format. Okay, there are worksheets on that course website. There are pre-videos already made. Okay, concerning, one second, hold on, let me check something. All right, there are pre-videos already made concerning the chapters made by Dr. Kim. Dr. Kim is in charge of she is the charge of Chem 130. So she has created a series of videos pertaining to the particular chapter. So you have an opportunity to get ahead and listen to her videos. And then obviously when I come on here, I'm going to talk about the same topic. And sometimes, you know, hearing someone else present it maybe helps you click in, you know, if you're having a challenge with a particular concept. Sometimes maybe the way I present it may not work great. Don't hesitate to view it from someone else. Okay, so Dr. Kim's videos are there. You also have those same videos on the course website. We'll get to that on Canvas here in a bit. Okay, course description, basically competencies. These are the 29 subject matters that we have to address. We address all of them throughout the semester as required by the Maricopa Community College requirements. And a textbook you don't need, like I stated, you don't need to buy one. We have all the textbooks there. You do need a calculator, specifically a calculator a scientific calculator. And it doesn't have to be one of these high dollar, you know, expensive calculators, you know, 10, 15, 20 bucks is sufficient. All you needed to have is to be able to do scientific notation. We're going to get into scientific notation, but basically you need a calculator that can do that, because we'll be doing calculations that utilizes extremely large numbers or extremely small numbers. And we use scientific notation to input those numbers into a calculator. Okay, attendance. Well, obviously attending one of the requirements of attendance is being here on the Zoom. Now, you know, you can treat this as live and being in person. Sometimes you can make it to class, sometimes you can't, but you are required to attend Zoom. That fulfills one of the requirements of attendance, and doing weekly assignments, because we're going to have a number of homeworks, a number of activities. You should be on Canvas, you know, doing something for that week, besides just doing the classes here, the lectures. Now, if for some reason you don't participate for 7 days, either through assignments or through Zoom, then I have the requirement to drop you. I don't want to do that. Okay, so I check on that. I keep eye track on that, and I will send you an email if you start getting close to that, seven, that magical 7 number, okay? All right, now, if you're taking the lecture right now, along with the lab, if you withdraw from the lecture for whatever reason within the first 10 weeks of class, the department requires that you also withdraw from the lab. The lab and the lecture are 2 separate courses, okay? So that's a requirement. So if you need to drop the lecture, maybe consider doing it on the 11th week, so you don't have to drop the lab, okay? All right. Now, also, I need to find out from the department. The question is this: if you take the lecture, which you're obviously here, it used to be that you also had to take the lab simultaneously. I don't know. I just sent an email to the department head to find out, to clarify if that's a requirement. So let me find out. As soon as I find out, I will shoot an email to everybody. Basically saying if you're here at the lecture and you not signed up for the lab, you may need to sign up for a lab. Let me find out if that's a requirement. Okay, I'll make sure that I get an answer by the end of the day. Okay. If for some reason you need to withdraw, especially toward the latter parts of the semester, I can't withdraw you. I can put in a withdrawal, but if you take the final exam, I cannot submit a withdrawal. Students in the past have, kind of have a wait and see attitude. Let me take the exam and see how I do, and then request a withdrawal. Now, I can't do that. In fact, the system won't allow me to do that. So think about it before you request a withdrawal. Now, a withdrawal can affect you if you're taking VA benefits or scholarships. That can affect your hours and run into financial problems. So think carefully about it. You want to talk about it, send me an email. We can meet through talk to your advisor, or you can email me and we can discuss it. But hopefully we don't have to reach that. Okay, I think everybody here should go through it and finish this class. All right. Okay, now here's the grading scale. Nothing special, standard 90, 80, 70 scale. Okay, A, B, C, D, etc. You will have an activity approximately, one for every chapter. The lowest one will drop, and that constitutes the activities constitute 25% of your grade. You have homework. Okay, first point number 1, everything is online. Nothing is on campus. Everything is online. Your homework's online. There are 14 homeworks. Not 15, because there's one homework that includes 2 chapters. Okay, also 1 will drop, the lowest will drop. You'll have 5 exams throughout the semester, and those exams are worth 30%. And then you have the final, which is 20% of your grade, and the final will be comprehensive, which encompasses all of the chapters 1 through 15. Okay, normally the final exam is all multiple choice. No, sure, all totally multiple choice. The exams are not. The exams could be, some short answer types. Now, keep in mind, the activities and the homeworks are roughly 50% of your grade. Okay, 50% of your grade. They do take quite a bit of a weight. All right. If you have to miss an exam or something, let me talk quickly about homework and activities. The homework and activities are open until December the 13th. That's the last day of class. Okay. Now, that means that you can do those all the way up to the 13th. However, the thing about activities and homeworks, they all will have due dates. Okay. So if you miss the due date, you can still do it, but there is a penalty for doing them after the due date. And I'll talk about that here in a second, what that penalty is. So keep that in mind. So the activities, you have no time limit, and you only have 1 attempt for each activity. The homeworks, you have no time limit to do the homeworks as far as within, once you start them, okay? But there, there are 2 attempts for the homeworks. Now, what some students do is they go in there and do the first attempt to give them an idea of, where they're at with respect to that chapter. And then once we're done with that chapter, then they go back and finish the second attempt to see if they can get a higher grade. If you're happy with your grade with the first attempt, then so be it, okay? Exams, they are specific days. And all their exams will be on Tuesdays. And they will open up as far as at noon, and they will stay open until 10 p.m. that night. Okay. All right. So you have a time period to finish that exam. Now, they are timed. All exams are timed. The regular 5 exams are timed at 75 minutes. So give yourself plenty of time. The exams will shut off at 10. Please don't come at 9:30 and hope to knock it out. Okay, so give yourself plenty of time. And if you have to miss an exam, let me know ahead of the time if you can, so we can rearrange for an alternative date. I can go 1 or 2 days before or after. I can't do more than that. So look at your schedule. The days that the exams are due, what we're going to do are etched in stone. Those are the days, so you know ahead of time when they are due. And so look at your work schedule, family schedule, and make sure that you're able to do that at those particular times. The same is true for the final exam, which is 110 minutes. And so you're gonna have to give yourself time there to accomplish, to finish that final exam. And let's see, there was something, activities were done or not. Okay, if you miss an exam, the exam 1 through 5, and you can't make it up, and you have a legitimate excuse, and you can't make it up for whatever reason, I have the okay to take your score of your final exam and substitute that for one of the missed exams. Okay, so if you do an 80% on your final, I can take that 80 and drop it in through exam 1 through 5, one of those that you miss. I can do that only for 1, so please don't miss more than 1. Okay. All right, excuse absences. The latest one I had, which was pretty interesting, was their excuse was, the gentleman's excuse was that he partied too much on his birthday and wanted to be excused from taking the exam. And I'm like, I'm sorry, guy, but should have taken the exam the day before, then party the next day all you want. So partying is an excuse absence. Okay. All right. So let's see, late work so far. The late work, and that's only for the activities and the homeworks. There is like I stated, those 2 activities and homeworks remain open all the way through December 13th. They will have due dates. So if you want to do them, if you miss the due date, you can still do them. But there is a penalty, late penalty, which is 10% per day. Okay, until you reach the 50%, which means that after the 5th day, day number 6, if that assignment was, say, worth 10 points, now at the most you can get, if you got everything correct, is 50 points. So half of what it's originally worth. So 50 points is 50% is a lot better than 0. Okay, given that your homework and activities are worth all total 50% of your grade. So you can still do them. So don't get in that position if you can. So where you're gonna have to make up stuff. Then you got the penalty to deal with. All right, I talked about the late exams, academic integrity. The exams, we're not watching you. I don't have a webcam going on, but we do look at the log. I log what happens when you take the exam. Canvas is noting if you leave the exam. And so after each exam, I go through and look at the log and check to make sure that nobody exited the exam. So don't do that, just stay with that. Stay within your exam, don't move on in different website where you're doing the exams. With the homeworks and the activities, no problem, you can do whatever, use whatever resources you need to do those activities. Okay, here's the tentative, and I state tentative because the homeworks and the activities, they're related to the chapter. So I won't expect you to turn in anything. I will not set the due date until after we're done with that chapter. And normally those due dates I got up here are fairly okay, based on previous experience and realizing how long it takes to get through a chapter and so forth. But it can be adjustable. It can vary depending on the class. Sometimes I got to slow down. Sometimes I speed up. Now, the first 2 weeks are going to be a little bit intense. We're going to have a lot of information thrown at you. You're going to be kind of busy, but after about the third weeks, things stretch out and it's a little bit more not as active. Okay. And so what I'm saying is the activities and chapters, those are adjustable with respect to due dates. If we haven't finished that chapter and we're still talking about it in a lecture, then and that due date is today, well, that's incorrect. I will move it, and if I forget, don't freak out. I will eventually catch up and move it. Okay. I will always give you 1 or 2 days, 2 days after we're done with a chapter to have anything to do with respect to homework or activities. I can't do that with exams because that's pretty much set with respect to the whole department. Only on rare occasions I have to get special permission, but you can see there the week of September the 3rd, that Tuesday we have first exam, which would be chapters 1 through 3, and they're spread out pretty good here. All right. 5 exams, and then a week after the last exam, number 5, we have the final exam. We try to put in the corresponding lab to kind of show you. We try to keep the lecture and the lab somewhat together. Sometimes it's quite challenging, but I think we do a decent job to cover some of the stuff in lecture, and then you cover it in the lab. Okay, any questions right now at this point? All right, pretty much the rest of this material is, something for you to read. There's not much. Those are the main points that I wanted to look at to make sure we understand what is required and how things are graded and so forth. What I want to do is share the website. Okay, and I put it in student view because my view is a little bit different. So this is the view that you should see. And if you haven't been in Canvas, which I believe a few of you have not, because I can see who's been in there, you really need to go in there and make sure you be familiar with it, because everything you need for this class is right here. Okay. On the far left is the home button, the home click. You also find the Dr. Fred's Zoom room, which obviously you already found it since you're here. And then I do record all of our meetings. And then once they're recorded, they get converted to MP3. And then I upload them to my YouTube channel. I have a specific folder for this class. For both my GCC classes and SCC class. They get uploaded, and then YouTube has to do their conversion, and then finally it gets published. So it takes a little time, but I will do my best to get everything up the same day, if not the next day, of what we talked about over that day. So in case you have to miss something or you want to go over something, you can always have my videos on top of that. What some students have done is subscribe to that channel, so when it gets uploaded, they get notified, okay, you got a new one. And people go in there and then take a look at it. All right. So there's my YouTube channel there for all these meetings that we have. We have announcements. I do communicate both email and announcements. I've already added a number of announcements there for you that you may want to go in there and start reading. There's a variety of different topics, things to help us through the semester. Okay. So a lot of good information there. Now, this whole thing, this whole Canvas class is set up in modules. Okay, for you. We have the welcome and syllabus module. Okay. Now, if you have not done so yet, we got tables here that you need to print. I mentioned earlier that Canvas, when you're taking an exam, Canvas is keeping the log of your activity. And if you happen to maybe use the electronic, the file and toggle over to it, it would think you are out of the exam and mark it. Well, we don't want that to happen. So these two tables are tables that we're going to refer to quite a bit. One is a periodic table, which is not the one I have in my background, but there's a periodic table that we're going to use throughout the semester, and hopefully if you print that out, you can have it all written up, because you're going to be able to gather a ton of information about atoms and compounds based on their position on the periodic table. The other one is a shapes table, which will allow us to use to predict the actual shape of molecules and their geometry. Okay, so get those printed out so you can have them. And there's an image check to make sure that you are seeing the image. Now, Canvas tech support strongly recommends that you use Chrome to use the Canvas, because I guess it's more adapt to it. Using an alternative browser, there are times that the images, you have a question with a particular images are not viewed. So do check, do stick with Chrome if you can, okay, to make sure that you're able to see the images that are uploaded for a particular question. Then we have a welcome video that some of you have already submitted. That's off to you guys. I regraded some of those that have been sent to me. And then there's a little activity concerning the syllabus, okay? Now, the next module is something, these are simulations that we will utilize throughout the semester to give you a better idea about how an atom, for example, is put together. What are the main components of an atom? Then down the road, we're going to be talking about balancing equations. And these are simulations that will help you grasp the concept of that particular topic, okay? Then, which brings me to the chapter. So every chapter has its own module. So everything you need is in that module. Module number 1, which is matter, okay? We have an overview. That overview tells you what we're going to talk about for this particular chapter. It's sort of like a quote study guide to help you out, okay? You have the PDF text file for that particular chapter. Some are short, some are, varies in as far as pages. This is a text. The chapter, the book for this particular course was developed by GCC, Dr. Kim and another professor that put the textbook together. We did that because a lot of textbooks are, well, not the best in the world, but it's so crazy expensive, and so we want to help your students out to get you some textbooks that you don't have to pay for. Now, the videos that I mentioned that Dr. Kim already pre-made are listed here. Chapter 1 videos, complete list of reference. Those are the ones that you, if you want, you go in there and listen to what she has to say concerning chapter 1. Okay, so that gives you helps you out with that particular chapter, an alternative presentation, I should say. Then there's a worksheet for that particular chapter that gives you kind of problems for that chapter, problems that you will probably find in the exam for that chapter to help you out. We started to introduce a practice quiz to help you out, give you more practice with quizzes. So we're only up to chapter 6 at this point. We were having a little bit of a challenge with the software, but we got practice quizzes up to chapter 6 and working on trying to get the rest up. Hopefully we can do that. Then we have homework online homework for that particular chapter, okay? And then there's an activity for that chapter. So that occurs for every chapter. You can see every chapter has that set up. Now, you will find that some modules have in it the exam, and you'll find that the exam is in the last module for this example. Exam number 1 covers chapter 1 to 3. So we put the exam number 1 in module number for chapter 3. Okay. And some alternative information to help you out. All right, so you go through all the chapters, very similar setup. We've added some additional resources for you to help you out. Here's the final exam chapter, which will have a course evaluation for us at the end, and then the final exam, which is not available to the 13th. There is a big module here that is a good resource. They're talking about chemistry, but the main point is kind of aid you and help you out as far as taking notes. This is something you can use and utilize to all your classes. Okay, taking notes is somewhat of an art, and there are different techniques. Reading those techniques and listening to them, yeah, of course, thank you, sir. No problem. Studying is kind of subjective. What works for one person doesn't work for another. You have to find your way, but to find your way, you have to see what other people are suggesting, and then take the best of what you think works for different ways and create your own hybrid method. Okay. So anyway, there's a lot of techniques, a lot of resources that you can take away and utilize in other classes to help you out. Okay. And I would have incorporated here, because some people like to take the PowerPoint slides that I utilize, print them out, and make their notes on that. That's a perfect good. It's one of the techniques of taking notes. So I provided for you in PDF format the PowerPoint slides for every chapter. Okay, to help you out. So we have all that, and let me see what else. Okay, that's the lowdown on the chapters. We have the syllabus here link, which is basically tells you here, okay, I think 99% of the information that you need is in the syllabus. Okay, so if it's not, send me an email and make sure I get it answered for you. Again, here's the syllabus if you want to view it online or if you want to download it. There's a course summary, which I kind of like, so you can see what's coming up, all the assignments for you. Obviously, you got the little calendar up on top right. Your grades gives you a breakdown. I believe this one too, you can do a what if situation by putting numbers in there. Okay, the assignments link breaks up the assignments either one or two ways. You can sort them by the date that they're due, which I like because you know what's coming up and what needs to be done, or you can break them up based on their group. So whatever works for you. Additional resources for you, tutoring, and so forth. Now, there is a study mate that I went ahead and initiated, and what I've done is I uploaded, I don't know, 100 and some examples, and you can go through all this. You can use this for other classes too, not just chemistry. But this one, what I created was, what I'm gonna do? It's not allowing me to do it. Give me 1 second. Activate it. All right, now we're cooking. Okay, so if you go to the study mate, you should see nomenclature practice. What it is, we have a chapter on nomenclature. Nomenclature is a fancy word for name that compound. Either you are given the formula, and from the formula you determine what the name is, or vice versa. And this will help you to be able to do that. So we're gonna do a lot of go from right to left and left to right, back and forth. So given the name, give me the formula, or given the formula, give me the name. So if you click on nomenclature practice, you have this. My recommendation is stick to the flashcards or matching. The other choices, some of these names, you have to use parentheses, and the study mate doesn't understand what a parentheses is. So I would stick with flashcards. Those 100 and some compounds I uploaded creates a flashcard for you. And so what it does here in this example, you're given the name, and it says phosphorus trifluoride. So you can, on a piece of paper, write the formula for this, and then flip the card, and it gives you the formula. Do note that this doesn't support subscript. So what should be written in reality, and I wish I did. I sent an email about saying, hey, give me some subscript. What it should be is PF, then subscript 3, which tells me I got 3 fluorides. Okay, so that's the way it should be presented. It's not, and doesn't support it, but that's okay. It still helps you out. Then you go to the next card, and there in this case, you're given the name, lead Roman numeral 2 iodide, and then you can come up with the formula. Okay, and we're going to learn that when we get into a chapter about naming compounds. And I'll be presenting that names as we progress, as we go along. So, you know, it's not too much of a surprise to you when we get to it. Okay, so that is study mate. And then that's about it right here. Okay. So tons of information, I understand. But if you're not looked at Canvas, do so. Go in there, be familiar with that, because there you have everything you need. Okay. And if you don't know where it is, let me know so you know where it's at, because I really don't, hopefully not mid-semester and be where can I find the textbook? Okay. It's all there. I should try to organize it for you so you don't have to go running around. I see some courses where they throw this Canvas course, they throw stuff all over the place. You're like, where's everything in it? Okay, any questions? All right. I just saw your chat. Yes, you're welcome, Stephanie. Yeah, some of these textbooks are crazy as far as costs. I can imagine. Anybody paid like $250 yet for a book? Yeah. Wow. We're trying to move not only GCC but SCC moving to what's called OERs, Open Resource Book. A lot of us, our scientists, are making books that make them available. There shouldn't be no reason why you have to pay that much money for a book. Okay. Any questions? No, because, you know, that being the case, well, put your trays up in the upright position. Okay, we're gonna jump in right into chapter 1. Okay, chapter 1. Let's progress. Proceed, I should say.
I wanted to ask, this presentation that we're covering, these are the same presentations that are also in Canvas, correct? You already said that.
The present, what I talked about up to this point is not on Canvas. But this one, chapter 1, yes, the pre,
Okay.
yeah.
Thank
Yeah.
you.
Yeah, no problem. Every chapter has videos for it already pre-made. Okay, well, we're going to talk about matter. Okay, specifically, we're going to talk about obviously chemistry. And so one of the big questions I always ask is, well, what exactly is chemistry? What is it? Well, in a nutshell, chemistry is the study of the composition. You know, we write these forms like carbon dioxide, CO2. Well, that is the composition. That is composition of carbon dioxide. Carbon, 1 atom of carbon and 2 atoms of oxygen. Okay, we study the structure because it gives us a lot of insight as to why certain chemicals react the way they react or behave the way they react based on their structure. We're going to study about the properties. why certain chemicals are very fluid and flow very readily, while others like honey are thick and very viscous and don't flow as well. But yet we know that, why is it that we can take honey and heat it up, make it flow faster? Something's happening there. We're going to talk about all those things. We're going to talk about the physical and the chemical changes of matter. Physical changes would be things like water. Classic example, we use that quite a bit. Water has the formula H2O. Everybody's heard that. 2 hydrogens, 1 oxygen. That is the formula. That is the composition of water. There are 2 hydrogen atoms bonded to a central oxygen atom. There's always going to be a central atom when we talk about composition and structure. And you're going to always be told who's the central atom, and then everybody else is bonded around it. Okay, so oxygen's central atom, 2 hydrogens are bonded to the central atom. We know that we take some water, liquid water, we stick it in the freezer. What do we get? We get ice, right? If we look at the structure of ice, it is still water, H2O. Okay, if you take that ice and you stick it in a pan, hot pan, what is going to happen to it? It's going to melt, right? And as it melts, it goes into the liquid phase. Well, the structure, the formula, the structures change, whereas in ice is very ordered and structured, but now in the liquid phase, not so ordered, more flowable. But the formula is still the same. It's H2O. Hasn't changed, still water. And if I continue to heat that pot that has that water, eventually it vaporizes, right? It boils. And that vapor is still H2O. That is what we talk about, physical changes. The structure has not been changed. The chemical structure has not been changed. Unlike a chemical change, where, you chomp down on a hamburger and chew that hamburger down, you take that meat, okay, break it up, you ingest it, you incorporate that carbon that was in that meat. Now it's incorporated into your body. And for some of us like me, it goes into the belly, okay, but it's still carbon, okay? It gets completely changed, but it's now a different structure, and that is a chemical change, okay? Now, well, we do know that all matter is made up of atoms. Now, the concept of the atom is not new. It's been around since the Greek times, but we'll have a lot more to say about that. Specifically, we're going to talk about atoms and what atoms are made up of. Now, we're going to talk about 3 main atomic particles of atoms, specifically the protons, the neutrons, and the electrons, okay? We now know that these guys are made up of even smaller molecules, but that's beyond the scope of molecules, components. That's beyond the scope of what Chem 130, okay? But those 3 are the main ingredients of atoms. And they make up what we call the atomic mass, which is really fascinating to me. Was you got a proton, we got the neutrons, they got relative some heavy weight on them, and then we got the electrons that we scientists have basically said, okay, they got no weight. They're so smooth that we have a relative weight of 0. They don't weigh anything, but we know they do. There's a weight there. And a particle so small has a gigantic effect on how chemicals behave. And they're electrons. It's the same thing as you walk on carpet, on your shoe, you touch something, you zap yourself, those are electrons. You wake up in the morning, your hair's like, electron. There's electrons up there. Tiny particles change everything, okay? A lot more to say about that. We're going to talk about chemical bonding because that's where the electrons are happening here. These electrons are 2 things are going to happen. We have 2 types of chemical bonding. Think about this, all this chemistry that evolves around us, around the world, in the universe, and there's only 2 types of chemical bonding. One type can be thought of like 2 magnets where they come together, okay? There's nothing shared, but they just come together and they attract each other because they got a positive charge and a negative charge. And the other type of bonding is a type where these crazy electrons come into play and they actually overlap and they're being shared between 2 atoms, okay? 2 different types of chemical bonding, 2 different types of chemistry. And we'll again have a lot more to talk about that. Reactions. All these chemicals we have out here, there's only 6 types of different reactions. Okay. A classic example is this morning or sometime you probably traveled to work on a vehicle. What did you burn? Fuel. That's a chemical reaction. You burn that fuel to convert that energy to allow you to move the vehicle from point A to point B. If you had too much Taco Bell and you have antacid, you got a little bit of acid reflux because we have acid in our stomach. We have hydrochloric acid. What do you take? A little Maalox, a little Tums. Chemical reaction. The Tums is a base. The acid in your stomach get neutralized. Feel a little bit better. Okay. So we're going to talk about these reactions. The periodic table. There's a number of properties and trends about the atoms and the elements, I should say. And we're going to have a whole chapter on the periodic table on the trends of these elements. Acids, we have a whole chapter on acid, which is an example again in your stomach, hydrochloric acid, very strong acid. Okay. Bases, which is Tums as a base, and they happen to react with each other and neutralize each other. So there you go, the third type of reaction, neutralization reaction. You had a combustion reaction when you're driving your vehicle, and an acid-base reaction, which was a neutralization reaction. Okay. Electrolytes. I know there's a lot of drinks out there. You probably, after you're working out, you take a drink, you got electrolytes, you read about electrolytes. What? The electrolytes are nothing more than these atoms up here that have either lost or gained electrons. Okay. And they're very important. Your body wouldn't function like it functions without these electrolytes, specifically things like sodium ion. Sodium is very crucial and potassium and other multiple different ions, because without those ions, you cannot conduct electricity and you cannot conduct electrical signals from point A to point B, from your body, from your toe up to your head. Okay. So we're going to talk about electrolytes. Then we're going to have a little bit about mole. No, not mole. It's the mole. Okay. The mole. If I say to you a dozen, automatically you think of 12, right? Because a dozen represents a number, which is 12. I got a dozen whatevers, I got 12. Well, the mole is nothing more than a number. It happens to be a very large number. Specifically, I got to figure out what's going on with my pen here. It's acting up. I'm going to write this in what we call scientific notation. Okay. If I take this decimal point right here and I move it over 23 times, that's how big that number is. And this equates to 1 mole. Now, we talk about a dozen, that's a small number. Okay. But a mole is a very, very large number. If you were to be able to count, I'll give you an example. If you were able to count 1 number per second, 1, 2, 3, 4, it would take you thousands of years to get to the end of that number. That's how big that number is. Okay. So we're going to talk about the mole and how it plays a role in chemistry. Okay. Very important concept too. Stoichiometry. Okay. This here, stoichiometry, big old fancy word for looking at the ratio of things. You're already familiar with the concept of stoichiometry. Okay. A car, how many tires does a car need? That's a 4-wheel car. Okay, let me be specific. Obviously, I got a car, I need 4 tires, right? So that stoichiometry of the tire to a car is 4-to-1. If I have a bicycle, 2-wheel bicycle, its stoichiometry is a 2-to-1. A tricycle would be a 3-to-1. Chemical reactions have the same thing. When I react A plus B, sometimes it's a straightforward 1-to-1, but sometimes it could be a 2-to-1 or 3-to-1, or it could be an uneven number like 2-to-3 ratio. And that's what stoichiometry is all about, and we're gonna talk about. Okay. intermolecular forces. This is where the electrons play a role. Now, electrons are modeled for the atom is nucleus and then electrons roaming around. So everything around us is nothing but electrons. When you grab something, when I'm grabbing this pen, on my surface of my finger is nothing but electrons. On the surface of this pen is nothing but electrons. Electrons have a negative charge. And so they repel each other. And so when I hold on to something, I'm never really holding on to that object. I am, but down in the atomic scale, I got a gap between the two. I got a gap where the electrons are repelling because they're both negative charge. Remember this, negatives repel, positive repel. It's like the north and the north of a magnet. They repel each other, okay? And that interaction with molecules affect what we call these intermolecular forces. And that's why certain things like water and flow very readily, and things like honey flow very slowly when compared to two, because of the intermolecular forces of the molecules of the honey and the water molecules. We're going to talk about solutions, and gases have been removed, so we're going to talk about gases. Okay, now branches of chemistry. There's like any professional field, like medical doctors. You got your brain surgeons, you got your lung doctors, you got your bone doctors, and so on and so forth. Well, chemistry is no different. My particular field is organic chemistry. Okay, my job, my graduate days, I was synthesizing compounds. Some of these compounds were being tested for medicinal purposes. Some worked and some did not, but we were looking at the compounds. And now the thing that got me involved with chemistry, which is ironic, is specifically organic chemistry, because like I said earlier, I used to be in construction. I used to build things. And when we talk about chemistry, it's no different. It just happens to be in the molecular scale. You look at a compound and its structure, and you try to figure out, well, how am I going to remove this part and put this part in? And it's basically civil engineering in the atomic scale. So it was easy for me to just float in there. So that was organic chemistry. But you have people who are inorganic. Most of those deal with metals. You have biochemists. These are chemicals that deal with obviously life. You got physical chemists who deal with the physical properties of chemistry. And like Dr. Kim Smith, her doctorate's in chemical education. So their emphasis is teaching chemistry. Okay. And there's environmental analyticals and a big list, all kinds of different groups. So different fields. Now, I'm not going to tell you that chemistry is the most important class you ever take it. I would never say that. No, I may think that. I'm just kidding. But chemistry is involved in literally every aspect of your life, either directly or indirectly. Everything that we utilize, okay, at one point in time involves chemistry to either make it, to synthesize it, to do something. Everything here deals with chemistry. The batteries deal with a chemical reaction. Chemical reaction from the plus and the negative end to form electrons, to form a battery. If you're running your electronics on the battery right now, you have a chemical reaction in your battery that forms electrons, and these electrons are utilized in your electronic device to run, okay, chemical reaction. So it kind of touches everybody. All right, so what we utilize is what is called the scientific method. And there's some steps to the scientific method, and you probably have used it yourself without really knowing that you were using it. You're just making you aware of it. Okay, so I'm not telling you anything here that you may not be already aware that you just naturally know. Okay, for scientific methods, first step is to make an observation. So, for example, you took a soda pop container and you stuck it in the freezer, and you come back and poof, it exploded. So you stop to think, well, what happened here? Why did it explode? So you formulate a guess as to why it exploded, and we call that a hypothesis. Okay, I'm gonna do a hypothesis and assume, okay, what must be happening is that water, when it became ice, must have expanded. And that can account for the fact that my soda can exploded, okay? If you ever live in cold country, you probably saw that also. You have water pipes that busted. Because water has a unique property that it expands. Yeah, when it freezes, when it goes from liquid to solid. So you research your hypothesis, you take a look at your best guess, your hypothesis, you see if someone else has done something. Any publications out there to explain the phenomena that you just observed. All right. So other than that, maybe there has, or maybe there hasn't, but you take a look, and then you may want to test your hypothesis. You want to test your guess. And what you do is you maybe design some experiments. Maybe you try do it again. Again, maybe it was just a fluke. Maybe it's just the phase of the moon that caused that. So you do the experiment again. You might try different containers. You might try different liquids. Okay, you might try non-aqueous systems. See what happens. Try a variety of different experiments to see what could be happening when you do that. Okay, so you take all that information, that your observations and the results of your experiments, and you analyze your hypothesis, and you maybe even have to repeat it. Okay, because obviously what you want is all your experiments, you want them to be repeatable. You don't want them to be, sometimes it works, sometimes it doesn't. That means there's a problem there. Okay. Then you draw a conclusion and put it all together, and hopefully maybe you can put it together as a paper and send it out and get it published in some scientific journal. And what hopefully will happen is other scientists will take it and repeat your experiment and get the same results. Okay. Eventually, as more and more people get the same results, and no matter all the different experiments done, the hypothesis can be elevated into maybe a law, okay, like the law of gravity. All right, so observations are crucial, things like being specific and making good note taking. A note about note taking, I think I didn't mention this, but some advice that my research advisor gave me 100 years ago with respect to note taking. He said, and this held pretty good. He said, when you write something down, write it in a manner so that you can read it 5 years from now and understand what you wrote. Okay. Because if you come back 5 years from now and you look at your notes and you're like, what the heck is this? Then you did do a good job of writing your notes. But if you write it so that you can read it again, and more importantly, that someone else reads it and understands what you're trying to say. So I try to attempt that throughout my career, and it has come in handy. Especially when we got into scientific legalities, and I go back 10 years and I had good note taking. It supported what I had to present. Okay, so we look at things like color, we look at clarity, we look at the state of the matter. We got 3 states of the matter that we're going to deal with: solid, liquid, and gas. There's actually 4, but we're not going to deal with those. The 4th one will be plasma. If you ever seen the Northern Lights, that's the 4th state of matter. Those pretty cool looking pictures. I've never seen the Northern Lights, just pictures. Okay, but we're going to deal only with 3: solid, liquid, gas. Matter is anything that has mass. Okay, and we also know that all matter is composed of atoms. And we're going to learn that these atoms are composed of protons, neutrons, and electrons. Now you will see that in the periodic table, we have all these elements. The proton defines what that element is. The moment I lose a proton, I made a new element. I can lose neutrons and electrons all day long. I can lose and gain them all day long, but it still remains that element. Okay, the element still defines, the proton defines what that element is. Okay. All right. That part will become clear here in a bit. We have, I've got a few more minutes and I'll stop it here. We have these diagrams that we use quite a bit. These diagrams kind of depict what we're trying to show, what a solid looks like, what a liquid looks like, and what a gas. And you can see that a solid, you know, we got these spheres that represent the molecule or an atom, depends on whatever it is. But you can see how ordered it is, very structured, very ordered. That obviously, that diagram represents a solid. Liquids, on the other hand, though they're still together, they're a lot loose, they're moving. Okay, so that diagram depicts liquids. And when we get a diagram that depicts a gas, the molecules, the compounds are totally separated from each other. There's no interaction. What's interacting close to each other are these intermolecular forces. These guys, these gases, they don't have a lot of intermolecular forces. That's why they're all separated. The liquids have a lot more intermolecular forces than the solids. The solids have very strong intermolecular forces. So solids are atoms packed tightly in very rigid pattern, and they do vibrate. They're sitting there moving, okay? And liquids are also packed, but they flow. And you can tell, you know, you can deduce here that as far as compressibility, I can't compress that solid very much. The atoms are close together already. And remember, on the outside of these spheres are electrons. I got negatives outside. They're repelling each other. They're gonna now want to come closer. I can't get them any closer because first there's no space, and second of all, the electrons on the outside are repelling them. Okay. The same with liquids. I cannot compress them anymore. But gases, there's a lot of space there. You know we get a tire pump, we can pump up a tire because there's a lot of compressibility on that tire. Okay. So anyway, we will continue. Why don't we stop it here? And we will continue on Thursday. Let me see what slide are we on. We got 4:15, chapter 1, slide 9. Continue. Yeah, so jump on those assignments. There's a couple of activities need to be completed by this week. So I will get them graded as soon as I can. I get them all knocked out by the end of the week. I try to get them down to you, back to you right away. So if there's something that I need to grade. So any questions? No? Well, have a safe time out there. I'll see you all on Thursday. Okay. And,
Actually, I have a question.
yeah, sure. Go ahead.
I did email you. I wanted to know if we were able to print out the chapter 1 OER text.
Yes.
Okay.
You can print, all of that is yours. Any PDF,
Perfect.
any PDF file that you see on the course website, totally yours. You can print out. Don't sell it though, unless you give me my 10%. I'm just kidding, just kidding.
50
No.
cents on. No,
50 cents on the dollar, something like that. No, everything's there. That's a lot of printing. So, but it's still a lot cheaper than, buying, $200 or $300 for a book. So,
Mhm.
it won't have all that fancy pens and all that. Hello, come here. I got my assistant here. Come here, Ruby Rose. Oh my goodness. There she is. Say hi. This is Ruby Rose. Marie Duarte. Yeah. Okay, she's like, what's going on? Anyway, you guys take care. We'll see you on Thursday. Okay? Stay on top of it and try not to get behind. Okay? Say bye-bye. Can you say bye-bye? Muchachita, say bye-bye. No, you don't want to say bye? Okay, she don't want to say bye. All right. All right, guys, take care. We'll see you Thursday.
Thank you.
Thank you.
Thank
Enjoy the
you.
rest of your night. Bye.
Good night. Bye-bye.